Hi guys. Because of time, I don't think I'll be able to do both worksheets, so I'll do worksheet number 1 or A. First question is double integral from 0 to 1 x minus 1 x plus 1 and x dy dx. Now what does this mean? This means now if you do the dy first, it means that your y is between x plus 1 and x minus 1, and your x is between 1 and 0. I think you need to sketch. Sketching always helps with these type of questions, so if you want to sketch this, this is x, this is y, this is 0, let's say this is 1. Now both of these will be straight line. So if I extend this a little bit, if I take this straight line, where x between 0 and 1, at 0 it's 1, at 1 it's 2. So at 0 it's 1, and at 1 it's 2. So this is the upper region, which is this straight line. If you do this straight line, x, y, you also put the limit 0, 1, because x is between 0 and 1. At 0 you get minus 1, at 1 you get 0. So the first point is 0 minus 1, second point is 1, 0, you connect. This is the upper region. So the region between them is this region here. This is what you're actually sketching, what you're integrating, sorry. So what you need to do is to integrate this. Since we're doing the dy, so x dy integral of this would be, it's a constant, so it would be a constant y. And you put the two limits, x plus 1, x minus 1. And you still need to integrate this from 0 to 1. You substitute the x plus 1 minus, you substitute the x minus 1. And you're still integrating from 0 to 1. Take this inside, x squared, x minus x squared plus x dx. Cancels, cancels. So you're integrating from 0 to 1, 2x. Now the integral of 2x is x squared. 0 and 1. You plug 1, so you have 1 squared minus 0 squared. Answer is 1. Good? So that was the first question in your worksheet. Question 2. From 0 to 1, root y to 1, 1 plus x cubed to the power 9 dx and dy. I want to show you something first, because you might see a question like this in the exam. So you first try to integrate this, but you notice that we're integrating dx first. So I'm going to do something, then I'm going to erase it. So if you integrate this, you'll see that we have a major problem here, because you can't really integrate this, because there's no way. I mean, if you think of u substitution, for example, then you find du, and you get rid of the 3, and you don't want to see the x squared, so from here you solve for x, so y minus 1 equals x cubed, so y minus 1 to 1/3 equals x, so your du over 3x squared equals dx. Then du, instead of x squared, we use this, so that's u minus 1. 1/3 squared would be 2/3. So if I write this integral now, the inside is u. Instead of dx, I write du 3u minus 1 2/3. So you see, it's getting more complicated this way. You can't really solve for this u substitution. And if you think of any technique, you know, there's no way you can integrate 1 plus x cubed 9, especially there is nothing outside. But if there happens to be something like x squared, yeah, we could do like u substitution. So that means if you see something that cannot be integrated, then you have to switch. Make the dy first and then the dx. But how do we switch double integrals? We know dx first, so x is between 1 and square root of y. And y is next, and it's between 0 and 1. So we really need to sketch this to know exactly what we have. This is x, this is y. So if I say that this is 1 here, this is 1, this is minus 1, this is minus 1. If I look at the root y, for example, how it looks like, I mean, if you don't need to memorize it, or don't need to I mean, you don't have to do this extra step. This is just to help you figure out. I can design my table here for x and y, and let's put 3 numbers. Where y is between 0 and 1, I can put 0 and 1, and I'm going to put a quarter, 1 over 4. I'll show you why. If I put 0, 0 will give me 0. 1 over 4 under the square root. I put 1 over 4 because there is a square root for that. So 1 over 4 square root is half. And if I put a 1, it's 1. Again, you don't have to do this, but this is just to help you figure out how the graph is going to look like. So 0, 0, that's 1 point. Half with a quarter would be somewhere here. And 1, 1 would be this point here. So this is how it looks like. If you notice, this graph actually is like this. So it's like y equals x squared. So now you can say, well, okay, this is my graph. I know if this is my graph, y is limited between the upper curve. Upper curve belongs to the x squared, and the lower curve belongs to 0. For the x value between 0 and 1. So, switching the limits, we're doing the y first. So if we do the y first, so 0x squared, and then we do the x, 0, 1, and it's 1 plus x cubed to the 9, dy first, and then dx. I want to erase some of this. To integrate this with respect to y, so you have a constant. This whole thing is a constant, so result of the integration would be this y, because that's a constant, so the integration would be itself y, between 0 and x squared, and outside dx. And then you plug x squared, 1 plus x cubed to the 9, x squared minus 0, if you plug 0. So now you get this to integrate, and this is something we could handle. This is something we can integrate. This is U substitution. So I'm gonna start by letting you 1 plus x cubed, then du would be 3x squared dx. So that's du over 3 x squared dx. So this integral in terms of u would be u to the 9, and x squared dx would be du over 3, or 1/3 outside. So I put it in terms of u now. Integrating this, it would be u10 over 10 times 1/3, so like u10 over 30. Instead of u10, I can put this now. And I know my limits, 0 to 1. You plug 1, it gives you 1 plus 2, 2 to the power 10 over 30, minus, you put 0, 1 to the power 10 over 30. And you can write this, they share the common denominator, 2 to the power 10 minus 1 to any exponent is 1. So this is your final answer for the integral. These are the first two questions of worksheet A. So I'm gonna stop this video. This would be part 1. When we come back, we'll do question 2, 3 and 4 maybe.